industrial technical session. Today is my talk title is the Disposable Electrode Chip for the Electrochemical Detection of the Heavy Metal Ion in the Environmental Analysis. Recently, the heavy metal contamination has become the very serious problem, especially in the developing countries. The tragic consequences is that these metals cannot be removed by soaking, washing and cooking from our food sources. And according to the stipulation of the WHO, it is determined that these metals, heavy metals, should be in the controlled quantity to assure the public health safety. So let me start my talk with the heavy metal toxicity. As we Indians, we know the kitchen is the very important part or part of our home. It is the place where we can enjoy good meal and mingle to each other. But the common convenience food and the gadgets found in our kitchen can put our health at the risk. These are the hidden toxic metals. Are we serious about that? We should serious about that because heavy metal toxicity has become one of the major healthcare problems nowadays. The heavy metal toxics such as arsenic, cadmium, lead and mercury has a high degree of toxicity and rank among the priority metals that have the great significance in the public health. The most, according to the U.S. International Agency for the Environmental Protection and the International Agency for the Cancer Research on the Cancer has found that these metals are generally the very these metals are the toxic metal and they can be non or probable carcinogens and can damage the multiple organs. And the most susceptible victims are the children and the pregnant women. If the pregnant woman exposes the high level of these metals may cause the miscarriage. And the children, these metals can reduce the growth and development of their brain. So it is very critical to control and determine the concentration of these heavy metals in our food and drinking water. There is the evidence we all know that the Bangladesh is suffered with the crisis of the arsenic toxicity. Their soil is contaminated. Their soil and the water is contaminated with the arsenic, and that is the higher than the permissible level. And so now there are the many reports have shown that these people are exposing there is a high level of the arsenic and showing the clinical pathological conditions that are the cardiovascular diseases, peripheral vascular diseases, and there is skin lesions, and they all also cause the cancer. So these are the evidence. We have to be taken the lesson, and we should control the quantity of these heavy metal in our foods and the drinking sources. There are the detection issues for the heavy metal toxicity. There are the two main reasons. One, that these heavy metals are very colorless and odorless. We cannot identify, and there is a lot of chances we have unwittingly exposed such high level of these heavy metals. Second is although there are several standard analytical technology to detect these heavy metals, but the main problem that this technology is very expensive, time consuming, and need of highly skilled operators and very big labs. Therefore, we need such a device that have affordable, we can purchase at the low cost, that is accessible, we can take these heavy metal at the home, and it should be portable for the field applications, and it should be sensitive that can detect the trace amount of these heavy metals. So before talking about the electrochemical devices, I should want to give you a brief knowledge about the electrochemistry. What is the electrochemistry? It's the phase where it studies about the chemical reaction that takes place between the interface of the electrode and the ion solution. Here, that involves the electron transfer from a species or to the species by applications of the external voltage. So generally the electrochemistry has numerous applications in the analytical chemistry, and it is the emergence of the several electrochemical biosensors and the sensors. Here is the electrochemical biosensor and sensors. The principle of these biosensors, generally these electrochemical sensors composed of the two parts. One is the receptor and second is the transmitter. Receptor generally recognize the target. It is specific to the target, and recognize the target very sensitively and selectively. And second is the transmitter that transduce the recognition event in a measurable physical signal. And there is the three cases. Generally the electron transfer from the target, and another is setting in the previous setting. There is the two receptors, and in the second receptor is tagged with the electroactive tag, and the electron transformation around the working electrode, and each signal identified by these electrochemical biosensor, we can detect the target molecule very high specificity and selectively. When we talking about the electrochemical biosensor, the one popular name comes into our mind, that is the glucose sensor. I think you already know the glucose sensor. This is the most popular electrochemical biosensor that is have the high impact commercialization value and again the popularity for the glucose monitoring for the diabetes management at the home. The glucose sensor generally implies the use of the enzyme that is called the glucose oxidase. This glucose oxidase generally catalyze the glucose into the hydrogen peroxide, and the de-glucose the lactone, and the hydrogen peroxide is electrochemically detected and this the concentration of the hydrogen peroxide is proportionally to the concentration of the glucose. This is the mechanism this glucose sensor works. Here I am happy to introduce the Japanese company where I am working. This is BioDevice technology. This technology is born from the Japan Advanced Institute of Science and Technology, and this company was established in 2003, and the founder of this company is Professor Ishikawa. He is a well-known scientist, and he is the professor at the Osaka University. And the main aim of this company to commercialize the product of these universities into the market. This company's company is developed the biosensor. It has an expertise in the high sensitive chromatographic chip construction, and it also constructs the DEP-Chip series for the giving the platform for the electrochemical biosensor. Now here we will talk about the disposable electrode printed chip, or direct name is the DEP-Chip. This chip is very small in size, and it has the electronic properties, and it has three electrodes: the working electrode, reference electrode, and the counter electrode. And this is very the material generally used for the working electrode is gold, carbon, platinum, or silver. According to the analyze we want to analyze. The another product is the potential state, generally used for the giving the external voltage to measure the electrochemical measurements. It is very lightweight. Generally, the conventional potential state very large in size, and it is very small in size, just palm size, and very easy to use. And it has the software. Using this software, we can measure the various electrochemical of this fabrication of the DEP-Chip. So, and interestingly, these chips also can be prepared on the ski, on the stress ball, and the underwater garments, and used for the high alert signal. And so, advancing of these DEP-Chips is going on. Here is the various type of the DEP-Chip series. Here is the round DEP-Chip is differentiated according to their working electrode shape, their materials, and you can see here is the round working electrode chips, square working electrode chips, or according to the PCR tube, it's modified to the PCR shape tube shape, and the working material used for the working electrode is the gold, platinum, and carbon. And this DEP-Chip can be manufactured or synthesized according to the need of the customers. Or this slide is showing the DEP-Chip advantage. This DEP-Chip is very small in size and it is disposable. There is no chances of the contamination. It is very easy to use and it can be produced in the mass, and it is very cost effective and high quality, and generally use the very small volume, 1 to 2 microliters, and it can be used for the various for the constructions of the various electrochemical sensor or the power sensor. Here I will explain you this is the cartoon picture of this device. Generally very small setup for the indoor analysis. Here we use the DEP-Chip, potential state, and the laptop. And laptop and the potential state connected with the USB to supply the power. Here we demonstrate the application of the DEP-Chip for the detections of the heavy metals. This slide is showing the analytical technology which used for the heavy metal detection, that is the differential pulse anodic static voltammetry DEP-Chip. This technology is unique for the each heavy metals. And here you can see the principle of this, what happens, how we can detect these heavy metals using such technology. Here is the metals. Generally, these metals found under their cationic form, and these metals reduce to the corresponding metals. And when the potential voltage is applied, these metals again oxidize and back to their original form. And this reaction is very fast, and this electrochemical reaction is very fast, and the peak intensity we obtain here is proportional to the concentration of the metal. And interestingly, this method is described in the 1920 by Jarosz Slade, and he won the Nobel Prize for the chemistry in 1959 for developing this method. Here we optimize the condition for the analytical detection of these heavy metals for the cadmium, lead, and arsenic. For the cadmium and arsenic, we found that the gold working electrode is suitable, while the lead, the carbon working electrode show the characteristic for the lead. So here we investigated the analytical performance of the gold DEP-Chip for the detections of the cadmium. Here we got the responses for the DPV responses for the different concentration of the cadmium, and we found the linear calibration curve between the concentration of the cadmium and the peak current in a favorable manner, and the range we can detect here from 5 to 160 dBd, and according to the standard deviation of the blank sample, we determine the lower limit of the detection of the cadmium is around 1 ppb. Now we also perform the analytical we also investigate the analytical performance of the carbon damping for the detection of the lead. Here we also tested the different concentration of the lead and found and got the DPV responses, and we also got the favorable wide linear calibration curve for the concentration of cadmium and the current we obtained. And the lower limit of cadmium lead detection we found it is less than 1 ppb. And we also tested the carbon depth for the simultaneous detection of the cadmium and the lead. Here we can accurately detect out the cadmium and Kb in the standard solution. And these results show that the DEP-Chip has the efficient for the detection of the heavy metals in the standard solution. Here we use, laterally after optimizing the condition for the BICON, we use the real sample. We selected here the Indian rice sample 1 and 2, and for the positive control we use the Chinese rice that is already known or dented with the 300 ppb cadmium. However, here is the question: why we tested the rice here? Because the rice is the most stable food, and around 3 billion people taking it every day, and it is a food crop that is mostly polluted because it requires the water irrigation of water, which may be polluted by this raw seaweed effluent and untreated industrial wastewater. We also tested here the Indian noodles using the DEP-Chip, and here is the water sample we have taken from the company lab and tested for using the DEP-Chip. This is the general permissible limit that is approved by the FDA, EPA, USP and WHO. The arsenic is the permissible limit is 1.5 ppm, and cadmium in the solid food 2.5 ppm, and lead 1 ppm, and mercury 1.5 ppm. Here is the before using the DEP-Chip for the measurement of these heavy metals. There is the preparations we have to do. We have taken the 2 gram of rice powder and cleaned it for the overnight in dilution for the acidic dilution. Here, and after the dilution, filter off with the filter paper, and column series, and again purified with the column, and eluting the 0.1 molar HCl. This is the protocol, but we will not go in the deep. Only the important point is this: that the sample solution we prepare, the pH of the sample should not be less than 4 or not more than 6. Here is the demonstration, real picture of the device of the DEP-Chip potential Sept method, and it is very small setup. There is no need of well-equipped lab, or it is very easy to use. Here is a small video where we due to a shortage of time, I will not show you, but later in the workshop I will demonstrate you the results of the detection of the cadmium in the Indian rice sample 1. Here we applied this DEP-Chip technology for the detection of the cadmium in the Indian rice, and the result we obtained that the quantity of the cadmium in Indian rice sample 1 found is around 300 ppb, that is the lowest in the permissible range. And this we also use Chinese rice that is tinted with the 300 ppb cadmium, and it shows that the DEP-Chip method is accurately calculate the amount of the heavy metals in the food stuff. Now this is the result of the we also tested the lead in the mean red sample 1, and here we found the quantity of the lead in the mean red 1 around 60 ppb. This is also below the lower limit permissibility of the lead in the solid food. Here we test, this is the result of the lead detection in the mean noodle sample, and according to this DEP-Chip analysis, we found the Indian noodle contains 110 ppb, that is also below the permissible level, and this result shows that DEP-Chip is very efficient to captivate the amount of these heavy metals. Here we detected the arsenic in the tap water and taken from the Japan, and we found the quantity of the arsenic in the tap water around 10 ppb, and that is also in the permissible limit. Now I conclude my presentation here. The DEP-Chip is regulated on the good for the electrochemical measurement, and it is very sensitive to detection of the lead and the cadmium in the rice and the noodle sample. It is also found sensitive for the detections of the arsenic in the tap water sample, and we can believe that these simple and clean preparation of these methods can have the scope toward the mass production of these DEP-Chip for the sensor development for detections of the heavy metal analysis. Now, we also believe that DEP-Chip holds the promise for the wide applications in the environment, biological and food analysis. Now, I am my presentation to provide you with and healthy life. Thank you very much for your kind attention.
Thank you very much, Dr. Madhu. I think it is one of the wonderful technology that we can use in our daily life. So very one quick question, if you have anyone? No? Then if no, I think Dr. Madhu is also planning to introduce this DEP technology in Jaipur, because he already installed one company here. So many of you can be part of the research, use the technology, and for many other applications can be done in future. So thank you again, Dr. Madhu, for making this nice presentation. So the next, another industry from India, in fact from Jaipur city, Rakesh Saini, who is the scientist and in charge of National Test House. And I would request Dr. Rakesh Saini if he can introduce.
That is also below the permissible level, and this result shows that DEP-Chip is very efficient to captivate the amount of these heavy metals. Here we detected the arsenic in the tap water and taken from the Japan, and we found the quantity of the arsenic in the tap water around 10 ppb, and that is also in the permissible limit. Now I conclude my presentation here. The DEP-Chip is regulated on the good for the electrochemical measurement, and it is very sensitive to detections of the lead and the cadmium in the rice and the noodle sample. It is also found sensitive for the detections of the arsenic in the tap water sample, and we can believe that these simple and clean preparation of these methods can have the scope toward the mass production of these DEP-Chip for the sensor development for detections of the heavy metal analysis. Now, we also believe that DEP-Chip holds the promise for the wide applications in the environment, biological and food analysis. Now, I am my presentation to provide you with and healthy life. Thank you very much for your kind attention.
Thank you very much, Dr. Madhu.